Today we're going to look at multiplying rational expressions and just simplifying rational expressions. So we're going to start by simplifying. The goal is to get any common factors that are on the top and the bottom and cancel them. And the thing that you need to remember is that these things are not factors. X squared minus 4x minus 12, that's not a factor. You can't just take this x squared and this x squared and say, oh, hey, they match. Let's cross them out. Ooh, there's a -4 and a -4. Cross them out. These are addends and subtrahends. These are things being added and subtracted, not factors. In order to cancel factors, we have to first factor the top and factor the bottom. So if you remember, factoring is like what times what would give us -12 while at the same time adding up to -4. Ways to get 12 would be 1 times 12, 2 times 6, 3 times 4, 2 and 6. If we did 2 and -6, that would multiply to -12 and at the same time add up to -4. So the top factors into x plus 2, x minus 6. The bottom, there's really no x term in the middle, so you're looking for two numbers that multiply to give you -4 and add up to 0. Those numbers would be 2 and -2. Or the shortcut, this is difference of two squares. Perfect square minus a perfect square. The factored form is x plus 2 times x minus 2. Once you have it fully factored, now look at the numerator and the denominator. Is there anything that matches on the top and the bottom? The x plus 2 and the x plus 2 match. They will cancel each other out, leaving us with our answer, x minus 6 over x minus 2. I would like you to pause the video and try number 2 on your own. Hopefully you tried number 2 on your own. We need to factor the top. We're looking for two numbers that multiply to give us -6. Those same numbers have to add up to -5. I think 1 and 6, if we make the 6 negative. So the top factors into x plus 1, x minus 6. On the bottom, this is difference of two squares. X plus 1, x minus 1. The x plus 1's cancel, leaving us with x minus 6 over x minus 1. If you want to leave your answers with parentheses around it, that's fine, but you don't need it. Number 3, you should be able to factor the top on your own. You're looking at two numbers that multiply to give you -4 and add up to 10. The only way to get -4 would be, or to get 4 would be 1 times 4 or 2 times 2. That won't add up to 10, so that's not factorable. So the top actually stays x squared plus 10x minus 4. It can't factor. The bottom, however, I wanted you to see what happens on the bottom. This factors into x times x plus 10. So see how both of these have an x in common? You can pull that x out. If you take the x out of x squared, you're left with x. Take the x out of 10x, you're left with 10. In this case, this is the simplified answer. There's no way to simplify it further. Number 4, multiplying rational expressions. Basically, multiply the numerators together, multiply the denominators together, and then we're going to cancel things out. So on the top, 5 times 6 is 30. X squared times x to the 3rd. We've got 2 of them, 3 more of them. That makes x to the 5th. We've got a y. That's like a y to the 1. And we've got 2 more over here, so that's y to the 3rd. On the bottom, 2 times 10 is 20. There's just an x. That'd be an x to the 1st. Y to the 3rd, and 1 more would be y to the 4th. Now let's simplify. 30 divided by 20. This is just a normal numerical fraction. So 30 divided by 20, you can divide both of those by 10 to give you 3 halves. or you can punch it into your calculator and let the calculator do the work for you. 30 divided by 20, math button, enter, enter, 3/2. X to the 5th, you got 5 x's on the top. X to the 1st, you've got one of them on the bottom. This one on the bottom is going to cancel out one of them on the top, leaving you with 4 on the top. So x to the 4th. Y to the 3rd over y to the 4th. These 3 will cancel out 3 of the 4. So there won't be any more y's left on the top because those 3 are going to completely cancel out. This one, it'll cancel out 3 of the 4, leaving us with 1 of them left over. So our final answer is 3x to the 4th over 2y. Pause the video, try number 5 on your own, then play the video to check yourself. I multiplied the numerators, multiplied the denominators, and this is what I got. 108 divided by 81, think of that just like a normal number fraction, and if you need to, use your calculator to help you. I got 4/3, so this is 4 over 3. For the x's, think about it. You could take this x to the 7th and write it as x squared times x to the 5th. We're canceling out the x squared, leaving us with x to the 5th. Or these two cancel out 2 of the 7, leaving 5 left over. You could write this y to the 8th as y to the 6th times y to the 2nd. Y to the 6ths are going to cancel, leaving us with y squared on the bottom. Or these 6 are going to cancel out 6 of the 8, leaving us with 2 left over. And that is our final answer. If you need to, pause the video, try the extra example. I'll put the answer up for the extra example in a couple seconds. On the next page, we are going to now start multiplying rational expressions. Basically, you want to factor the top, factor the bottom, factor the top, factor the bottom, and then see if anything on the top cancels anything on the bottom. So step 1, factor the numerators and the denominators. If it's only 2 terms, think about what 4x and 4x squared have in common, and actually, I hate it when it's written like this. Really, it should be negative 4x squared plus 4x. If you were to factor that, they have negative 4x in common. If you take this and pull the negative 4 out and pull an x out, you'd be left with an x. If you take 4x divided by negative 4x, you'd be left with a negative 1. Anytime the second exponent is bigger than the first one, rewrite it with that term first. It'll make a lot more sense. Then this one, we're looking for 2 numbers that multiply to give us negative 6. Those same numbers need to add up to 1. That would be 3 and 2, but the 2 would need to be negative. So x plus 3, x minus 2. On the bottom here, we're looking for 2 numbers that multiply to give us negative 3 and add up to 2. That would be negative 1 and positive 3. So that one factors into x minus 1, x plus 3. And this one would just be 4x. The interesting thing here, you could rewrite this negative 4x as negative 1 times 4x, and that might make things look a little bit better. Now, optional, you could write this all out as one big fraction. You really don't need to do that step. Basically, if there's anything on the top that matches anything on the bottom, you can cross it out. So the 4x matches up with the 4x. The x plus 3 matches. The x minus 1 matches. So all that's left here is the negative 1, the x minus 2 on the top, nothing's left on the bottom. That is our simplified answer. I was going to go through example 7 with you, but yeah, I'm actually not. So you can ignore example 7. Let's go to example 8. Example 8 is very, very similar. It's just that the second fraction is over 1. So we still need to factor, 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 factor. So the first numerator, thankfully, is already factored. I'm just going to stick it in parentheses to make it look nice. X squared plus 2x plus 1. We are looking for, two things that multiply to give us 1 and add up to 2. That would be 1 times 1. So that one factors into x plus 1, x plus 1. This one is only 2 terms. Anytime there's a negative in front, you want to think about factoring out a negative. So these are going to have negative 1x in common. And actually, x to the third, x squared, they have x squared in common. If we take this, take the negative out, and take 2 of those x's out, we'd be left with 1x left. 3 divided by negative 1 would be negative 3. And we're taking the x squared out. So it's just going to be that x minus 3. And then over here, we've got a 1. So what cancels? Just the x minus 3. And our final answer is x plus 1. See how there's 2 of them? That would be squared over negative x squared. Here's the weird thing. The negative should go on the top. Anytime there's a negative, it doesn't really matter if it's on the top, on the bottom, or in front, but it's just best to put it on top. So that would be your final correct answer. I am going to go through number 9 with you because I want to make sure that you remember all of the different ways to factor. This top thing is 4 terms. I don't think there's any like this on your assignment, so you probably don't need example 9. You really just need the previous examples, but just in case, if we have x cubed plus 5x squared minus x minus 5, you split this down the middle. What do these two have in common? These two have x squared in common. Pull x squared out of that, you'd be left with x. Pull x squared out of that, you'd be left with 5. These two have negative 1 in common. These parentheses should always match. So our factored form would be x squared minus 1. That's the x squared and the minus 1 times x plus 5. Although, this is tricky, x squared minus 1 is a difference of 2 squares. That would factor into x plus 1, x minus 1, and then we have the x 5. So that would be the factored form of this numerator. So let's go up here, x plus 1, x minus 1, x plus 5. And we've got the x plus 1 there. We're just going to kind of, there we go. X squared minus 25 is difference of 2 squares. That factors into x plus 5, x minus 5. And there was nothing but just a 1 underneath that. Okay, what cancels? X plus 5 cancels. That is it. Your final answer, see how there's 2 of these that are x plus 1? X plus 1 squared, x minus 1 over x minus 5. Okay, again, I don't think you're going to see any problems like number 9. You are going to see difference of 2 squares, so you need to that. And you are going to see trinomials that you need to factor using this blank method. So really, on your assignment, you're working on worksheet 5 today. Factor, 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 factor. Factor everything you can possibly factor. Then see what cancels out. Also remember, you're going to have problems like this, where you need to multiply all of the numerators together to get one big numerator, all the denominators to get one big denominator, and then simplify vertically. Simplify the number part using normal fraction rules, and then simplify the letter parts, remembering that 2 x's would cancel out 2 of the 7, leaving you with 5 left over, or whatever. Those are the types of problems you'll have on today's assignment. So get working on worksheet 5.